I actually did create a little GUI. Well, I added to the GUI where some files.
To the paste GUI?
Yeah, but I didn't check in because I didn't really want to go and put it in the right place. I just put it in the group name.
Oh, okay.
Yeah, I found out where those no pointer exceptions were getting caught.
Where were they getting caught?
Abstract module.
Where were they getting caught in abstract module?
I don't know, maybe I didn't get the latest version, but there's one track catch in the abstract module that doesn't have anything with no pointer exception, and it's blank. Maybe that's it. I don't. That's good.
Do you know how small abstract module is now?
No, I probably don't. Never mind. Alright,
No, but what could have happened was
you know, it wasn't crazy. I was going through and I'm like, I keep getting these errors and it's just keep going. I'm like, what the hell? No error?
yeah, because some of it, I mean, a lot of that is mainly just because it gets wrapped up. I mean, you're sure it was an abstract module and it wasn't getting caught by the thing that calls abstract module?
No, it was abstract module. But I think that might have been an old version of abstract module.
Yeah.
Now I think about it, I still have it uploaded.
Okay, I think we'll start off and talk about the network stuff. And then I noticed, Reed, you checked in a bunch of changes for the state saving subsystem, right? So you moved a lot of that stuff. Application launcher. Okay. Periodically. Okay. Okay. So once we get in configuration, we can set that because the typical thing is you want to have some sort of the user to be able to say something, but also applications to be able to say stuff. So then we'll do some sort of, looking at what the user wants and looking at what the application would prefer, and then we'll make a decision. Yeah. All right, I'm going to start off talking about some of the network stuff. What's that? All right, right now what we have is we have file manager able to transfer files, right? Files via a unicast pipe, right?
Yeah.
Okay. We have Richard's query subsystem. Which is through the what's it called? The resolver? Query resolver? The resolver service, which is multicast, right?
Yeah.
Juxtas.
I think it uses both.
Yeah, Juxta's one-to-many system. We have a generic. We have like kind of a rudimentary. We have a rudimentary broadcast pipe system, which is mainly what the applications are using, and then these two are being used by the file manager piece. Okay, so I think we need to kind of break these down into the more abstract, abstract network message types that we want. So I mean, obviously we have a query type of we have a query type of remote event. We have a object. We need object transfer, just in general, and that's what the applications have been using to kind of trade data within the object to make it look like they handle these remote events just like they would a regular local event. Okay, so we have a query And then we have object transfers. And then we have like bulk data transfers, like the files. Okay? So, what's different about these? One of the big limitations, I think, is the fact that the query system, the responder system, can only take strings. Okay, so that's a big limitation, I think, just because we will hardly ever be transferring strings in these queries. Most of our queries, strings actually, we'll be doing them occasionally because we'll do strings like in file transfer. Obviously, strings are a good.
Well, the transfer file, though, I don't use the query.
What's that?
I don't use the query for transfer.
No. Like when we query for file. What I'm saying is the types of queries that will come up.
Okay.
File transfers do obviously use strings, looking for file names, but like most of the other stuff we're doing, like queries for like when we orient and we say, hey, I want some. Does anybody have work for me? And then everybody responds back, yeah, I have this much work. So does anybody have work for me? That can be string based, but the response of I have from this size or whatever, obviously doesn't fit into strings. It's like if I'm going to say I have this size of a workload to give you, that needs to be different. But I think we need to look at some of the attributes of these different types that make them different. Like a query, the query is going to usually be a query and then response, and these two are very much tied together. And in an object sense, we kind of see this event as synchronous. Like we send out a query and get a response, whereas a lot of this other stuff is kind of fire and forget. You send out a signal and then you don't worry about what happens. You might see eventual signals come back. But this query response mechanism, what I've noticed in like a lot of the application development is this is different from like I got done with work and I want to say, okay, here's my work, I'm done with it, right? Or I need everybody to gather this work or whatever. Is different from some initial things that happen, like when you orient, where you say, hey, I need work. Oh, I have this much work, and then you'll pick one and then actually go talk to them. Okay, so this query response, we need to find a good way to kind of add some synchronous behavior to this. And right now, Richard is waiting in a loop in his query handler in the basic broadcast mechanism that I've been using for some of the application objects. I don't do anything synchronous. I just send it and hope that a message comes back, and then I have to do a bunch of comparison to see if it was in response to something that I sent out. So I think I like how Richard's doing the wait, but the only problem with that is we tie up that thread while we're waiting. Now I think a lot of that's not that bad, because you're really, if we're spawning new query handlers for each group, you're only tying up the query handler for the group, which, at least in the applications that we've been doing so far, that's not too bad a thing, because we don't really have a lot of events where we're doing a lot of different queries. But I can see us eventually doing that. So I don't know if we just want to tag them as synchronous or not synchronous, or something along those lines. Because some of them can't progress until they get an answer back, so they might as well do it synchronously. But some of them, I don't know. But this subsystem really needs to fit this I want, I have types of queries that we're doing in a lot of the applications. We're doing it in the parameter sweep, and then I've ended up doing it in the clustering application as well. So, because like for example, just as a typical conversation that like a dialogue that happens in my clustering application, is I get to the point where, like for example, if my data pool is empty, I just started up and I need to kind of orient myself, I don't have any work to do. What I end up doing is my kind of data factory will ask the network, ask for work. Okay? All the nodes out there will respond by saying, this is probably not good. I'll ask for work, and then all the peers will respond basically with a size, and that is how many work units they have that they could give to you, like how many data points they could give you from their workload. Okay, and then the data factory. So back on the data factory side, we'll find the biggest. Okay, we'll determine the largest size, and then it will request work from winner, and then I'll have a data transfer.
And that's the part where you can't transfer somewhere.
Yeah, I've run into a limitation where, with the mechanism I'm using, the rudimentary broadcast pipes, the pipes can't handle data big enough to transfer this data. Which, I mean, is a silly limitation, but I didn't want to do it that way anyway, broadcasting it. So it really doesn't matter that it's limited in that way. But this mechanism right here, and then also, this mechanism is very inefficient as well, because I have to broadcast the one that I've chosen back, and then the other guy will get that broadcast and then respond. This would be better in some sort of one-to-one communication where I say, okay, you've won, give me your data, and then that other peer can break that piece of the data off of their workload, because you can't break that work off here, because if you don't win, you've just gotten dumped work that you're still responsible for, right? So that's when we run into that also with parameter sweep, where you say, oh, I want to orient, and then you kind of have to say, oh, okay, you've won, and then once you've won and you're sure that they're going to take the data, then you can pull it out of input factory and then send it, right? So I think this pattern will come up a lot.
That's pretty much the same thing.
Yeah, and it fits the model of what you're doing with the file in a lot of ways. Okay. The only difference being is that if you have actually, do you do like a winner type system where?
Well, I leave that to file manager.
Right.
They can get multiple responses.
Well, I mean, they might, but you probably respond to the first one.
Yeah.
So that's the only slight difference.
That's on my side, though. I mean, that's on that. If you wanted to, you could wait
right.
for more responses.
For more responses and then find the biggest.
Yeah.
See, now, and that's the problem. And the big problem is this: is that asking for work, no problem. That's generic enough that you can just code that into the query handler, right? When you get to here, this comparison and choosing one, that has to be done on the application object side. It can't be done on the responder side, right? Because the application side is the only one that has the logic to say this one's better than that one.
Yeah, you ask for work, and then everybody responds back. You just wait and take 10 responses, and then you can just look through and say, I want this one.
Right. So I mean, the main thing is just the messaging between the network portion and.
You can already do that, and then you can that way antivirus set up so you can talk to this one person.
Right, and then we go to the directed unicast here, and I don't think that's as big a deal as that. This request for work will come in when you see a pipe come up, talking to you, and the pipe will have. See, and that's the other thing is like your response is not necessarily what you promised or what you suggested in the first part. Because if you've been doing work, your size is actually going to be smaller when you actually end up sending it. But that's all right. What's that?
I don't want this. It's not big enough.
Well, we'd go into an input loop there, because then we'd say, I don't want this. Let me query again, and then somebody else would respond and say, oh, it's smaller. And then basically, if one of them got smaller while you were waiting there, they all got smaller. The only really big question is what if one got smaller faster than this one, and is now, or got small. This one got faster, smaller than somebody else, so now a bigger chunk of work. But we don't care. We just want a general idea of who's the best person to send us work, and then we'll get it. So this part I'm not as worried with. It's really this part, and the main thing is that I want to just be very careful about us tying up two threads at that point. The one on the application side as well as the one on the network side. You know what I'm saying? But when these break out into separate messages, into separate signals, it ends up being I need at least 2 or 3 slots to handle the transaction, which is a lot of code for an application programmer because it's like this is one thing. You know, it's like one thing that I want to do. I want to send a message and then get it back. But like for example, right now, this guy emits and asks for work, right? And then I have to slot the sizes, you know, the responses, right? And then I have to slot a timeout, which says I'm done collecting responses. Let me look at them. And then I pick one, right? So this guy over here, he has to slot the request. Right, from the peer. The peer asks for work, and he slots the request. You respond with your size in this. And then after the timeout, you'll emit U1, right? So you have to slot the final request, like the slot the query, slot the request, and then you respond, and then you slot the data. Right? So basically, this is 5 slots in one object, because this one's on another peer, but it's still the same object, right? So because this is our version of our instance of object, that's their instance of object. So that's like 5 slots just to do this transaction, which I don't know if there's a way around, but it would be nice if at least we had a standard mechanism of doing this. And I think doing something like this might at least consolidate some of these slots, right? So I don't know. We have some, I mean, the thing is that if we do some things like this where we have a method which says like, this is my slot, right? And I'm doing things like I say, you know, send a query. I'll basically emit a query to the, you know, the query handler, and he can go do that stuff. And then I can actually wait here, right, and then handle response like what you're doing in yours. Because even though I'm waiting here and tying up my thread, since I've already emitted, there's another thread running with that in it. Right? The only thing I have to be careful about, though, is that when I emit, I need to make sure it escapes my thread. So one way to do this is to emit directly to the network handler. Because see, we don't want to emit and have to have our abstract module have to handle getting that out to a higher level queue. What?
That's actually what I did.
What? You emit directly to another queue, right? So, but see, the thing is from the application side, we don't have that capability yet. Because the application side doesn't know the exact object on the other side. Right. Either that or we just have to get it to the application query queue above us or something. Something to the effect of emit this so it gets out of my queue, and then I'm going to sit here and wait in this method. See, because then you'll have what Richard has in his query handler on the other side, and that has a wait as well, right? So the idea is that on Richard's side we have the slot query, right? or something to that effect. And it's actually within one of your juxta handlers that you have this wait. But you'll do something like, query network, and then you'll have your own wait, right? Which is, again, fine because asynchronously outside of the network is doing stuff. So once you get the response, you can pass that back to this guy. So pass back to app object. Right? And then potentially wait here. Right? Because what you need to do is have the app object do all its comparisons and all that kind of stuff, and then get a response back to you so you can say, actually, no, we don't have to do that, right? Because he can actually just emit his final request, so we don't need that. But we can pass back all the responses back to the app object and have it handle it here. But notice it's in the same method still, right? So in other words, we get this done, and then we notify it that you're done waiting. We'll have a timeout as well, but you can notify a waiting thread by doing that notify all or notify a specific object, because we'll be waiting on a specific, whether it's object or the object itself. We'll be waiting in the thread. We can notify the thread, wake up. It can handle all those responses it got, and then from here, it can emit its final request. Okay, and emitting that final request invokes an actual bulk data transfer unicast, which will set up a connection with the remote object. By that connection coming up, it'll say, oh, they want work. So I'm going to do my calculation for how much work I'm giving them and send them the bulk data. So what we've done is, I think what we can do with this handles all of this, right? The requesting side, what will that look like? It'll look the same. That will be the same. What we've done is we've consolidated basically these two together. Okay? These two correspond with each other as well, right? When we say I have a final request. Oh. No, actually, all three of these become this, because we don't even have to. This emitting of the data. No, we still have to slot the data. That's how we get the actual data on. So.
Oh yeah, that's right here now.
Yeah, application side.
Yeah, it's a lot easier when I don't have to worry about that.
So this right here will be in response to this request, but these two can go together. I don't know. I just think this is more intuitive. It's more how you actually think of the query. Is not how, because right now what I do is I'll emit the query and then I'll emit a delayed event, and then the delayed event will eventually get something back. But here, it can, but I mean, no, that wouldn't be a bad way to do it. The only problem is that, I mean, we'd have to signal by a direct notify, not through a signal. Which I don't know. I think that's fine. Because essentially what we're doing is we're putting a lock on the collection. And then when the network is done collecting, it'll unlock the collection, and then the other method can progress. So what we're doing is we're kind of breaking out of a little bit of the object model and getting into actually directly working with Java objects again, which I don't think is a big deal as long as those objects are not juxta-specific or application-specific. They're generic enough that both sides can just unlock them at the Java object level. But so basically, this would be we'd wait on the responses, and then this guy would basically responses notify. Because notify is the unlock, and then that would unlock. The only problem with this is that this is two objects, a juxta object and a. I think this is a juxta object and an application object directly talking to each other. So I don't know. If that's good. I'd at least like it so that the slotting is not as much code. I mean, because this isn't a big deal right here, having these two methods, but it just, I don't know, it just doesn't feel right when you're writing it. Yeah, it's like, it's making the query and what you do after the query's done so far away that you can, I don't know, I just think bugs are going to get in there. But we need something along those lines. So we need to get this query handler to kind of, the query handler and the applications to use this kind of handshake idea. Now the unicast pipes, that's another thing.
Yeah.
Right now, how are you dealing with, since you're all in Juxta, you can deal with peer IDs directly. Application objects can't do that. Okay? But that's not too bad because we have the idea of the source and destination built into the signals. So the idea would be this. When I say, like, for example, we want the winner. We want to talk to the winner, right? But we can't say, go talk to this guy we can't tell the handler to say, hey, go talk to this peer ID, because we don't know what peer IDs are, right? But what we can do is go talk to this source. Yeah, like, basically, when you get your response back, the Juxta side is actually welcome to use peer IDs directly. So what he can do is put into a generic object, he can put in the source of that signal, he can put in, this is a winner, or like this is a response. So this guy can actually say, signal destination, right? You can do signal set destination to response get source. Right? That way we can use actual peer IDs without ever seeing them as peer IDs. We just see them as this is who responded to us. So when that signal gets to a kind of bulk data transfer or a unicast handler, the unicast handler could say, oh, okay, I'm going to pull out this object that I know is a peer ID, but they didn't even know is a peer ID. They'll pull it out and directly send to that peer. That peer will have a slot that says slot request. So in other words, when it sees this pipe come up, it knows that it's looking for work. But I don't know if we do that by the name of the pipe or in something in the advertisement or something.
That's where I think I ran into. That's why I just went to the ID.
Yeah, because I think advertisements you can put in other fields.
You can?
So I think having some sort of signal name in the field of the unicast pipe will work well. Because when you see that pipe come up, when you discover that pipe advertisement, you can generate a signal based on, you can directly generate a signal based on that. Because we need two things in that advertisement, on the unicast advertisement. On the unicast, we need, okay, we have a unicast, right? We have a source and a destination. Okay? Funny enough, the destination is the one who's going to initially emit the signal, right? The destination is the one who's going to say, hey, I want this. Okay? So the source gets a signal that says, hey, this guy wants something, right? Or can we bring up the pipe? We can bring up an output pipe, right?
Yeah.
And they can make a corresponding input pipe, right?
You bring up the output pipe, and then
They discover it and make themselves the input.
you can create
Yeah.
the output
What
pipe.
we'll do is we'll create
Or
an
you can
advertisement.
create the output pipe first, and then
Have them create the same using the same advertisement, create the input pipe,
Yeah.
so that they connect. So what you do is the destination needs to generate an advertisement. This advertisement needs some sort of name, right? Which is kind of like the source signal name. What I mean by that is some string over here needs to get it to the application object that's going to actually provide the data, right? So we create an advertisement with the source signal name in it, but this also has the peer ID of who we want to open this pipe, right? So this is the source peer ID. Okay, so we got the source peer ID from the responses. So we flip the source of that response to the destination, and then that ended up in here. Okay, so we set up this advertisement, and then we create the output pipe, or create the output pipe. Output pipe is the receiver, right?
input pipe is the receiver.
We create the input pipe. Okay, and then we sit there.
And now it'll just wait once it receives something.
We wait.
Yeah.
That goes on the network. The source receives the advertisement, gets the advertisement. It knows to act on it because its peer ID is in the advertisement. It says, okay, I need to create this. So what I'm going to do at that point is generate a local signal using this name. Using source signal name. And I'm going to emit this to the group to the application group I'm associated with, right? Because he received this in a peer group. Each peer group is tied to an application group. He emits that. Some object on the peer, right, will say, oh, this source signal name is slotted to this method, and this method is give work or something like that, right? So he'll package up his work and give it to the handler, right? The handler will then create the output pipe and send. And so wake this up, and we go on. I don't know if that's wait. This is more.
Just sit there.
Yeah, this is. But this is some sort of juxta-synchronous receive.
Because you don't have to do anything once you create the input pipe. You can just sit there and then.
But then we have the generic handler, and then we'd have to decode what we're waiting on and all that stuff in there. In other words, the juxta event handler. What I'm saying is I think when you create input pipe, you can actually do it synchronously, where you put a timeout directly on the create input pipe, and then just read it once you receive data. I think you can do it right there. So we need to do a synchronous receive here. We send here, and then that's done. Now,
And actually, yeah.
this will probably have to do with signals.
That just made me think I should probably change file manager too. Because I'm actually looking file manager with peer ID. Probably shouldn't, but it's kind of easy to.
Problem is, if we can get this working, this would also be a similar mechanism. I think what we're going to end up doing is taking file manager and moving it this way, and then seeing where we can make it synchronous where we need to, and then actually we don't need to move it back because file manager can just signaling itself. But this will be, I don't know, when we generate the local signal, I almost want to make the advertisement the network source in the signal. Because remote signals, remotable events, have kind of two scratch variables for storing network-related stuff. They have object, network source, and object, network destination. Okay, those are just generic things that the networking side can put whatever it wants in there. In this, it might be good to put, that's how we're going to send the peer ID. Be able to manipulate the peer ID is in the, network source network destination. I almost want to put the pipe as the source and destination on this one, on this remote event. That way, when I generate the local signal using this name, basically saying you've won, you've won the comparison of who's going to send work. There'll be a slot over here called slot request. That slot request will make the source we'll put the source into the destination, right? In other words, flip the headers so that it is now sending to that pipe. And then it will also package, it'll set the data, right, to the work. And then emit that back to the handler. What if we want to add in an emit and wait type of mechanism? Like in Swing. Swing has invoke later or invoke and wait. I think we need that mechanism as well. Invoke and wait being the synchronous style, because then we could do stuff like invoke and wait, and then once we've waited or whatever, we can continue on. In other words, once that event itself is tagged as handled, we can move on. Does everybody see what I mean with this? Because when we set the data and then we emit it again, this guy over here, this guy has gone away because he emitted and got done. So when it comes back and it sees the signal, it can create the output pipe using the destination there, the advertisement that's stored in the destination. So it can create the output pipe and send. This guy will receive it. Then we have our data. So that guy will still have a query handler, a request handler. Those are good, because this is just reporting how much work you have available. This is actually sending the data. So on the receiving side, we only have two methods, which both of those methods make sense to me. On this side, on the other side, on the requesting side, we've consolidated all the query mechanism into one, which makes sense. Querying and then winning and deciding. So that makes sense. And these two kind of correspond directly with each other. I have the send query side, I have the respond to query side, I have the request data, send data. That makes more sense to me. Just, the other little method was just another place for errors to introduce. And I think an invoke and wait might be good. And the invoke and wait would basically, you emit a signal, right? And you watch the signal that you emitted. And your signal that you emitted will get tagged in some way. And once that signal gets tagged as handled, you can move on. So this is a way to invoke almost a method on another object and wait for it to get to the end of that method and then be able to do something else.
students in this place.
But I think invoke and wait will let us have two objects from two kind of different worlds, like juxta and the application. Let these two objects be synchronous, but still use signaling. In other words, they can be synchronous, but they're synchronizing through something that they both understand, which is pace signals. So we don't have to do. I think we'll do something like that. I think that's a good way to do it. And I think we really could have saved ourselves a bunch of effort by just modeling it on Swing. Whatever Swing, or any of these other very popular event-driven mechanisms. So. And what we'll do is on this part, we'll take your logic from File Manager for transferring files, put it right in there. The query part, we'll kind of work with the query subsystem to put those together. I think the query subsystem needs to tie these two together, and basically, depending on how complex your query is whether it'll create a generic broadcast pipe or use the responder service. Because I think this responder service will mainly help us in performance, because it's ask a string, get something back, move on. That'll be a lot quicker. But there are still some things that we'd like to broadcast that are too complex for responder to handle. Because the idea of taking, like, for example, a serialized object, turning it into a string, and sending it over that is ridiculous. But I think we do want some of the mechanism of being able to do more complex things. So I think the handler, the query handler, this whole subsystem, should look at the event, the signal that it got that wants to send out a query. It should look at it and say, okay, are you a very basic data type that I can understand and I know how to turn into strings? If you are, I'll turn you into a query. If not, I'll create a broadcast pipe that is handled, that can actually transfer whole serialized data. In other words, can transfer byte arrays as opposed to strings. So, and I think the basic things that we need to handle, one thing I know we're going to run into a lot is like an array of a few integers or just integers. Obviously, strings could be turned into queries. I think this kind of I want this, how much do you have type of thing will come up a lot. So being able to do that in queries as opposed to. But I think we need to make the interface to these two things the same. In other words, you get a remote signal, and then you can decide which mechanism you want to do. And I think that this broadcast pipe will have to have that kind of really kludgy, I'm sending out a broadcast pipe, everybody can receive it, they can do something with it, and then respond, and then I'll have to have just a timeout or a handler, an asynchronous handler from Juxta that sits there. Whereas the query subsystem will be a little bit more synchronous. Because I think having it synchronous will really speed us up, where we don't have to sit there and wait for some sort of poll or anything like that. Because once I can do that, my protein motif clustering app should work, and I'd really like to see that because it's I got a data set from my buddy in the department, Bernard. He does this protein clustering stuff a lot, and I got some data sets of his that are like hundreds of megabytes and stuff. So I got huge amounts of data, and I also know what the general answers are to like from his experimental data. We'll at least know if we're in the ballpark of clustering it correctly and stuff like that. Yeah. So like kind of what the correct output would be. So what's that? See, that's the thing though, is right now his performance is really horrible because his whole thing's in Python, just because it's faster to develop in. So it takes a long time. But you know what? Ours is real slow too. And we'll eventually have to get to the point of looking at speed. But I think running on 26 machines, no matter how slow it is, I think we'll see something happen. So I really want to see that. Yeah, I mean,
Or efficient. I mean, you can throw a lot at it.
and that's the thing. I mean, it's like optimizing like what we need to focus on right now is optimizing communication, because anything that you can do on a sequential program to make it faster, we can do on ours as well. And I mean, whether that's leaning out the like the messaging subsystem or something like that, or making it so that we're not going through as many queues and whatnot, we can do that all day long with optimizing the sequential performance on the box. What we can't do all day long is make it so that our queries are faster, our joining of the juxta groups are faster, and all that stuff. So we need to focus on getting a good networking subsystem, because that's the only difference that's between us and like MPI programs and stuff, like MPI running on shared or on clusters, or pthreads running on shared memory machines and stuff like that. Their big thing is that they can just have data instantly go anywhere they want it to, whereas we can't. We have these, all these different signaling mechanisms and stuff like that. What we want to do is hone it down and do some of these like synchronous tricks and stuff like that, where we can really.
This actually might be cheaper.
What's that?
So this will probably be a lot cheaper.
Then what?
This week, as opposed to having one of those types of machines.
Yeah, but I mean, the thing is right now, I mean, even our communication's so bad that the machine wouldn't even have to be that expensive to be faster than than running on a few cheaper machines. It's like the machine doesn't have to be that big. I mean, the thing is right now, I mean, they're coming out with quad cores, and we have this laptop is like faster than some machines out there that like a couple of these machines together. So I mean, it's like there's a lot more cores out there these days, and multi-processor machines with multiple cores on each processor. I mean, the Mac Pros are like already at least 4 cores with the 2 duos in them. It's like we'd have to have we need to get really fast to compare to that. So so once we get these basic primitives of a query system, a bulk data transfer system, once we get that all solidified as what we want the signaling and the interface to look like, then we can start leaning it out. We can start really cutting out all this additional broadcasting. I wanted to turn the broadcast system that I put in there. I wanted to turn that mostly into synchronous as well, because I also run into another problem where the main problem I saw, and I mentioned it to you, is that when you put a signal in there, the handler sits there, and anybody who asks it will broadcast the handler there, because you don't know who's contacted you yet or not. Because you're not just broadcasting like you do on a network, where you can just throw stuff on the wire and everybody on the wire sees it. Since we're so heterogeneous as far as how we're connected. Right. It'll do both. It does, and that's where I'm running into a problem, is that the way that my 2 instances are talking to each other are through network broadcast, through network multicast. And it gets too big to transfer, because what they do is apparently they don't break it into multiple packets for you. So they just sit there and do, I guess, UDP on the local net. So you have to fit into the MTU, which is like 1,500 bytes, which is nothing. So it's like, if you can't fit it into the 1,500 bytes, it won't break it up for you and all that stuff. So, but it's trying to multicast, right? But then there's also the case of, what if somebody's not on your local net? Do I go contact everybody who's ever talked to me? Well, that doesn't scale. So do I wait for... So what they're left with is, a lot of times, is either coordinating through a rendezvous or having them pull them or something like that. In other words, having it pure pull instead of me push data to them. So if it's pulling, you have to have some time. So you have to sit there for a little bit and wait until you catch a pull. So doing it synchronously, I think, is at least builds in the timeout mechanism, so that you can sit there and wait a little while, but then take it out, so that some guy 10 minutes later who comes and talks to you, just because you haven't sent another message, will still get the old message. And whether they use it or not isn't really the point. The point is that you're sending it. It's like they have to actually transfer the data to decide whether or not they've received it already or whatever. So they're sitting there polling, and I don't know. It just... I think we can lean a lot of that out. All right, so how's the save mechanism looking? Serialization? Okay. So we got. Let me open up some of the. So you've moved some of this into. You've moved most of the logic into application launcher.
I put it all.
Okay, and this is mostly the quitter code, right? Reed, you need to get comfortable deleting. All right. Yeah. I've given you an entire mechanism an entire system. There's a server out there. We have all this CVS technology. You don't have to comment. Just delete it. If you want it back, go grab it. View history. Go grab it.
Actually, what I do is that I don't check email, so because I always break stuff. And you kept complaining.
No. I've tagged stable. You can check in You can break everything you want now.
Oh, really?
These days, I tag stable so that when I'm working on my stuff, I check out paste stable and I check out paste juxta stable and paste GUI stable, and I work on those. So you guys can whatever you want to do on what's called head on the main trunk, you can break that all day long. I don't care if y'all's apps never work. All right, my apps, I tag stable. I take a look at head every once in a while and see and sometimes I try and catch it when it compiles and actually works. And if I catch it when it compiles and actually works, I'll move stable up to that. So yeah, check in all the time. Okay, check in as often as you can within reason. Don't. The main thing I ask is don't check in stuff that doesn't compile. That's irritating. Okay, but make sure it compiles. Preferably check in more at points where you're reasonably sure that it kind of works. If it's something like if it's an annoyance, that's fine. Like one thing I ran into is like when we put in quitter, it quit, but you had to wait. So when I was going through these tight cycles, but I don't care that because at least it works. You know, at least all the stuff you put in there does what it says it's supposed to do. It's just none of the other things were responding, saying, "Hey, I've saved" or whatever. So that's all right. But for the most part, check in often because at the very least, someone can look at your work in progress and say, "Oh, well, that's almost there. I'm not going to work on that. I'll just work around it for now and then and go on." Okay, so you got your quick control in application launcher. I notice also that you moved the interface stuff into Paste GUI, which is good. So you have what? Do you have a delay in here? A delayed event in here? Okay, here you go.
Yeah.
10 times 60 times 1,000. Yeah.
Yeah, that's
10 minutes.
Main, and that just fires up and catches every 2 minutes.
Okay. All right. So when I quit, what happens? Do I just quit?
No,
It'll do one more.
We'll do one more save. If you can't save, we'll prompt you. Put it in there. Or you can continue trying to save it.
Right. How long does it wait after you emit a quit? 10 seconds? Okay, that's cool.
It saves fast. I realized that was funny. I'd be sitting there working and I go do something else and this thing pops up and it says,
Oh, are you sure you want to quit? Yeah. That took me a while. I was like, what's going on?
first I thought it was NetBeans asking me to show me.
No. Did I save everything? So yeah, we'll do all right, so serialization. We don't know where we want to put it.
Actually, I put it under serialized.
No. I mean, as far as where we want to, because you're not serializing the abstract modules yet, right? Okay. Okay, so we load app, and then we're running.
I think I just had some orders that we went for serialized.
And everything, and then done. So yeah, because we need it at as with anything serializing where you're customizing serialization, the hardest part is recursing down into the contained object. So what we need to do is in application, we need to add the serialization mechanism. Application launcher will ask each application to serialize all its modules, and then application will have some sort of loop where it goes through its modules and serializes all of them. Now, the hard part is that typically you do not serialize threads because it doesn't make, you can't save time, you know. So it's like, so the idea is you want to you're kind of requesting a serialization of all the things around the thread. So I think we want to do two things there. Well, wait. Okay, we always want to serialize while they're running. That way we can use the same serialization mechanism whether we're quitting or we're just pulling. So you want to save everything around it. I think we will need a custom serialization abstract module, but I think that means we need it in every object. We should just see what happens when we try to serialize an abstract module straight up. Just tag in abstract module as implement serializable. Honestly, I think it'll work with regular serialization mechanisms. The only part that won't work is the fact that it doesn't have any understanding of the run mechanism of thread. I don't know if it'll. What's that? Oh yeah, no. What I'm saying is I think it'll ignore all the thread related stuff like state and all that stuff. So yeah, and there's actually a built-in mechanism for restarting threads when you unserialize them. There's like some sort of method that's always called after you unserialize that you can actually put the start in there if you want it. I don't think we'll do that. I think we'll unserialize and then start them. Yeah, like when you read object, there's also another method I think that's called after that. It's kind of, I'm going to initialize you with the read object, but then I can call this other thing afterwards. Like it's almost like a, this is everything you do after you instantiate me type thing to handle these kind of temporal objects like threads. But I think we should see what happens if we add in a method on application that just says serialize all your modules. It knows all its it knows all its modules, so have it just iterate through its list and serialize them and see what happens. Because I think if we tag abstract module as serializable, we can just use regular serialization mechanisms in subclasses. In other words, if you need custom serialization, you can implement it. If you don't, you can just do the regular tagging of transient and all that stuff and go on your way. Now, and then, yeah, tucking them into a directory. The directory structure should reflect the application tree, so that basically it's actually just a list because we only have one layer, but for files as well.
Yeah, directory structure, like how
yeah.
should I set that up where we're saving? Right now, I'm just doing whatever I'm running /place/files.
Right. What's that? Yeah, I gave I put up a suggested on the wiki on some of these, I don't know, mechanisms that I've given you all to, you know, assist us in this kind of thing.
I tried watching the discussion board. I never got an email. I think you just blocked it.
I've banned you.
Can we use instant messenger?
No, what I do, you know what I do? Do any of you do RSS? I just RSS the recent changes page, and then it'll always update you on changes. But no, you might not have seen this because I put it on there a long time ago. I put this suggestion on there a long time ago. So no, it won't come up in like the most recent type stuff. It'll come up in the old things. Let me see what I got here.
Actually, I just don't know how to use it.
Okay, so I have the main directory. Basically, you have a client directory, a paste directory that has apps under it, and then individual files for the objects. I said that we should have some additional files which have some extra stuff, like the because you have to envision it like this. When you create an app, we go through this app launcher to generate the whole object structure. There's going to be an almost identical, if not integrated into that mechanism, the way of when you start up, finding these applications, instantiating them, and starting them running just like you would as if you were creating a new app. So the idea is the only difference is instead of using constructors, we're using, unserialization. So we unload them. We deserialize all of them, start it, and it should be back where exactly where as if application launcher launched it and ran it for that long. So, and then add a separate area for files, and I think that could just be a dumping ground for all the individual files. But this will be under a client directory. So this is where basically if you were to install this app, you'd install it into a directory. There'd be the paste jar in there. There would be a configuration file. There'd be a paste subdirectory and a file subdirectory. Here's how I think that the initial distribution would look. Like if you were to initially install this app. And this is, I think, how the files will work as well. Okay, so I've installed paste into a directory. Let's say this is my client directory. And I have the subdirectory named paste, but we can call it like applications or groups. Groups, let's call it groups. Okay, so we have a subdirectory called groups. And we have a subdirectory called files. Okay, inside paste we have paste.jar. By the way, we might need to rename paste. I think there's another parallel app up there. Either that or we need to make sure that we become wildly popular so people, when they say paste, they refer to that. Okay, so we have paste.jar and then we have like a paste.xml. Okay, and Nick, if you watch this video, paste.xml is your responsibility. But anyway, so paste.xml will be our configuration file. Now, the initial distribution will also, inside this subdirectory, will already have probably...
Oh yeah, wait, question.
Yeah.
Alright, our files... never mind. That's my answer.
So we have paste juxta and probably paste GUI, but this is optional. Right, because if we have command line ones, but anything that you have in the initial, that you want initially loaded will be in the files directory already. The reason being is that if you're running paste already, you can actually get all the other paste pieces directly from paste. So if I say, oh, I've been running the GUI, but I really want to run the console because I don't want, window up and stuff I want to run in the background. So what you can do is you can actually query the paste network for paste, paste console and get it, and then just alter your configuration file or in your GUI alter the startup and say, oh, instead of starting on paste GUI, auto start paste console. And that's because we're going to take that out of main. Right now we have it in main, but what we'll have is instead of that, we'll have the only thing in main is parse paste.xml, and then take all of the auto load stuff that's specified there and auto load it. Okay, so.
So file manager is going to have to be one of the first things loaded so that you can get like paste pictures from file manager.
We're going to move file manager into paste, and then it'll interact with the generic query and bulk transfer subsystem of paste juxta. Okay, right now you have most of your juxta logic in file manager. We'll have file manager be in paste, take all the juxta specific stuff, and then turn that into the generic query handler and the generic bulk transfer. So basically, we'll create a new file manager which has the original, the simple signals of, hey, do you have a file? Here's the file. And that will handle, that's all right that we can specifically say, look in the directory and look at files in paste safely, because we're not tied to a particular network subsystem. And then we'll just send signals over to juxta. Okay, so we need to move file manager into mainline paste. But, okay, so this is what an initial installation looks like, right? And inside paste XML, okay, inside paste XML, we have autoload, paste GUI, and we have autoload paste juxta. Okay, so those are that's our initial installation. We fire up, we load, we get our GUI up, and then we join the paste network and whatnot. Okay, now we create an app. I create a cluster app. So what will end up happening is groups will create a subdirectory called cluster or whatever we name it. So we'll have to start enforcing names too. Okay, but we create a cluster app, a cluster directory. Okay, when we create that app, if we're creating the app or joining the app, if we create our app or join the app, we'll put cluster. If we're joining the app, the file transfer subsystem will have transferred cluster.jar into here, and will be available now. If not, we had written cluster.jar and we copied it into here. Okay, because those are the two ways that we can get files. Either we create them or we download them off the network. So what would end up happening is cluster.jar would end up in here. Okay? And then we're running. Okay? Or actually, we've loaded cluster.jar, we've instantiated all the modules. As we're running along, we get a poll to save state. This will end up start generating data factory, and all the different serialization runs, right? So that's a typical run. We quit. We quit, all the files remain. When we load back up, we'll parse paste.xml, auto-load all that stuff, and then what we'll do is we will start iterating through the subdirectory tree of groups and start, I found a cluster directory. I'm going to create a cluster group. I'm going to create a cluster group and I'm going to instantiate all the different objects that were in there. We also want to put into the groups, we want to put in we need a peer group config. Basically, that'll be an advertisement, I think, for the peer group. Because we need to make sure that we open.
We should just end up installing a whole Juxta too. Right, when we do it, we're going to use Juxta.
What if you're not running Juxta?
If we're using Juxta, then
Will it still work if we're not using Juxta?
Not now. I mean, if you ever use the Juxta part, you're going to need.
It'll create it though. I mean, Juxta will create it.
But then there's that little stupid shell screen that comes up.
Yeah, we need to stop that.
You should create the Juxta folder and the config file yourself.
No, we need to do the programmatic configuration of Juxta.
No. I think I was looking. You have to do it.
Oh, but programmatically
Yeah,
configure Juxta is creating it? Well, then we need to do that with
yeah,
the
like you create the
we
platform.
need to do that with the
config.
user interface for Juxta.
Yeah, I think that's how. Like I saw one example where they got rid of that popping up, and they kind of encapsulated this class that changed the platform config file, and you could do certain things like control loose.
Okay, we need something along those lines because we can't.
Yeah.
But we also, I mean, that's just going to be built into, I think, paste Juxta.
Yeah.
Because
That's true.
we don't want. What we need to be able to do is have some generic peer info type stuff that we want to build, and then we can put it in there. Now, if we need to change specific Juxta settings, we need some sort of generic configuration where a subsystem can tell you, here's the settings I have, and then we can put in arbitrary stuff. That's what we need. We don't even have a configuration to load modules, to load our GUI and our networking subsystem. We're not going to create a generic configuration mechanism that can configure any possible networking subsystem out there. All right, let's we're gonna do this. We're gonna store these files in the paste project directory, but we'll CVS ignore groups and files. Okay? That way your local instance can do whatever it wants with those things. Well, let's do that. We need to build in this, like all the stuff. When we create a group, our new responsibilities are also include creating the subdirectory and things like that.
Pace does that? Pace will be in charge of creating subdirectory.
Paste needs to handle all the directory structure. Right now, you just have it creating a file that's the name of the class, .scr or whatever.
Yeah, and that's what I moved it out the case directory
Just the dot application. Okay. So let's just move that into a groups directory. Are you storing all the objects in the same directory? So we need to break that out into subdirectories. The other thing is we can't have the application object responsible for the name of the files. We do it by the class name. Object. Actually, we should do it by the class name. There's bad stuff. We have to do it by class instance. We have to name them by class instance because we have because some of these apps have multiple copies of the same object. Oh, you know what else? You can just leave it to the object view. We need to build into, like for example, some of the objects in paste juxta at least, which actually we don't need to serialize. Because it has its own caching mechanism. But other things that do this, where you have an object that comes up and then it creates new objects that the application doesn't know about, but it is using the event keys. But I don't think that's a problem because what you need to do, all we do is we have the object that creates the other objects is responsible for those objects. So either it needs to, if they're transient, you can just let them go when it's serialized and then just make sure it creates new object, or it can, whenever you ask it to serialize it, it should provide a custom serialization for those long objects. But the main thing that I want to make sure of is that if I write an abstract module, if I don't do anything and I only use basic data types, I should serialize correctly without any additional code. And I don't think we'll need to make a custom serialization for object module. I think we can just do implement serialize. As long as you store it in the right place and then start it when it gets loaded up, and we're good to go. It's good. Anything else? Alright, main things, doing that, moving around the serialization aspects, making the query and bulk transfer mechanisms more generic, move file manager into mainline paste. That's it. We need a configuration mechanism.
So what we said is, I got the video, but we said that the query handler would be able to create pipes, right? Is that, or whatever, not necessarily query handler, but something that implements the interface.
Yeah.
Would be able to create
Do both.
pipes.
Either use responder or use broadcast pipes, multicast pipes.
And then for the direct unicast.
Just do exactly almost what you're doing with file manager. But the main thing is we need to just look at where we can add in some synchronous operations for consolidating some of that query and response mechanism, and move the actual file commands of does it exist and that kind of stuff into a file manager object, which we'll move into paste. But make sure that all the signals that we're sending to file manager is regular old file types of signals, and then it just uses remotable signals to get remote files. Okay. Start thinking about some stuff to write, like words, not code. Just a report on some of the papers that are out there.
How do we get to the paper?
What's that?
How do we get to the paper again?
Let me see if I can move it to the wiki. But I'll send out the old link for the other ones and the username and password that I put on there.
If you instant message me, you don't get your emails.
CS reader,
Yeah.
Okay.
one of those things.
Richard's technology is so weak considering he's in technology. We need to write something. The main thing is read a paper type of idea. Give a good summary of what's going on, knowing that we've been working in this and we don't have to use these more general audience types of terminology or whatever. I want some relationship to like the kind of stuff we've been talking about. I want some criticisms of their mechanism, of whatever they wrote about. Some sort of here's the biggest contribution that they've done. Here's what I don't like about their their method or whatever technology that they introduced. Something along those lines. So general outline is summarize, introduce the concept. What they're doing. What their method or introduce what they're contributing. The strong points of it, the weak points of it, maybe some alternate ideas or ideas inspired by that you thought of reading the paper or how it can relate to the projects we're working on. Okay, it's a general idea. Just however long it needs to be to convey it. It'll probably just be like a couple pages or something like that. But something getting some data out of this because there's only a few more weeks left, and I just need some. I want to see some critical reading of some of these things on an individual basis. Read if you or if you have something else that you want to write about directly, you can do that. Like if you want to explore your idea of like this kind of peer-to-peer query caching type of mechanism, you're welcome to look at that. But do it in the context of looking up some of these other things about how people are doing queries and stuff like that. See how you fit in there, or file caching and stuff like that. What's that? Okay. So if you just want to work on that, along those lines, you can do that. Now, if you want to work on it as a full paper, then write me a couple pages that's a little bit more brief synopsis of what you're doing, and then you can use that kind of as part of the larger paper. Okay. If you do want to try and like work it into some sort of like conference paper or something like that, typically you're about you've seen a lot of these papers. Most of these papers that we've been reading have been from conferences, so they're about about 8 pages or so of that kind of double column. Well, it's definitely. I mean, if you're gonna work towards it, I mean, it's definitely a project to work on. I mean, something along the lines of. It has some very good elements of some complex simulation and that kind of thing, and some looking at some techniques. But I think the main thing is look into some of the caching mechanisms that are out there to make sure that you can really do something that is unique. So, but I do your searches in terms of caching because that's really what you're talking about, like creating some sort of query caching mechanism. And I think the hard part though is coming up with some technique to make the decisions. So, the general statement of I want to cache this much. That's a real hard question. What's seemingly an innocuous question is really a difficult decision to make. So, but you can look at it, and at the very least, it'll point you in some directions as far as what kind of attempts people have made to do something. But yeah, if you're going down that road of looking into that, that'd be a perfect thing to write something about. Just grab some material from some of the peer-to-peer stuff we've been doing, and use that as kind of the background for looking at that. But I definitely, if you are thinking of doing that, then definitely roll it into something that you can reuse. The couple pages you're gonna write for me. All right. And yeah, keep up to date on the wiki. Check into CVS. Give me what? I know the internet's is very intimidating. I know it's cold on the internets. And they're wolves, but yeah, I know you'll get used to it. I don't know. I'll see what's wrong with the wiki if there's something wrong with the wiki. I'm not gonna fix your email. Yeah, but I'll IM you some links to the papers. How about that?
Yeah, that might help.
You want me to write it on? Maybe I'll chisel it out of a stone tablet and give you that.
You know that way it can't change.